environmentally sensitive and cost efficient. And the reason we're all here today is due to existing conditions that are in need of improvement and are rising concern. And those are varying 2 and 3 lane cross sections throughout, no dedicated bike or pedestrian facilities. The pavements show heavy signs of wear. There's heavy traffic congestion throughout the length of this corridor. There are several areas that flood due to stormwater runoff issues. Secrist Middle School raises several concerns for safety, right-of-way access, parking, drop-off, etc. And all in all, the current configuration fails to meet the safety and serviceability expectations for a growing Tucson population. So what are we doing about it? Our design team is confident that our design solution checks all your boxes and can be defined by this simple scope of work. We want to expand the 6-lane highway with a center median and paved shoulders. We want to improve the horizontal and vertical geometry, as well as the intersection realignments and right-of-way expansions. We're going to implement traffic control throughout all phases of construction. We want to provide bicycle and pedestrian facilities, including an ADA accessible pathway. We've designed 2 new bridge structures to accommodate the expansion. We want to add additional drainage components as well as improve upon the existing ones. And like mentioned earlier, perhaps the greatest concern is improving the safety, access, and student drop-off and parking at Secrist Middle School. All the while, our design is backed by several aspects of value engineering that apply to the components listed below: the retaining walls, sustainability, Envision design, and the bridge design selection, which will be touched upon by the respective disciplines later. Without further ado, I'm going to hand it on over to Sergio, our roadway lead.
Travis. As Travis mentioned, there's only 2 to 4 lanes traveling, and which can get pretty congested during peak hours. And currently there is no sidewalk or bike lane, which makes driving the only method of navigating through Houghton Road safely. So I decided to go with a design from the roadway design manual. And I decided to pick this design because it provides 6 travel lanes, as well as a curved median, sidewalk, and shoulder that can be used as a bike lane. I also picked this one because it's familiar to the public, because it was this is a similar design south of Houghton, of the project area, which I felt it would be best to keep everything consistent. Some sections will require retaining walls because some of the end slopes extend past the right-of-way easement, as well as may interfere with the utility easements. Next slide. Another part of the project was designing the intersection for Escalante, and I decided to follow a similar design as the roadway design manual. Instead, I decided to go with 4 travel lanes because the traffic flow wasn't as intense as the one on Houghton. I decided to also add a left turn lane, making navigating on Houghton Road easier, as well as there's discussion whether or not to include a right turn lane or have people turn right using the rightmost travel lane. Further study is needed to come up with the final design. Next slide. There's some sections that may be easier or financially feasible to just extend the easement by a couple of feet, because some of the end slopes only extend past the easement by a couple feet, so it doesn't seem very economically sound to build and retain retaining walls in these certain sections, and they're marked in red boxes in the plan and profile sheet. And now I'll pass it over to Kristen.
Thank you, Sergio. So to begin, in the traffic portion of the project, we started off with doing a safety analysis. The roadway can be analyzed for safety to determine how to improve the corridor. The existing roadway was analyzed from data that was collected from December of 2004 to December of 2005, so over a period of 1 year. Based on that data, the rear end collisions are most common along the corridor, and these collisions were most often not caused due to driving violations or any unsafe driving by the vehicle user. So out of the 110 collisions that were accumulated within this year, 58% of crashes did not result in any injury. So from this, it can be concluded that a user in a crash is less likely to be injured than to be injured along the existing roadway. So these are just aspects to take into consideration when making safety implementations along the roadway. And there were no fatalities along the roadway either. So the future roadway safety analysis actually can also be assessed, and this resulted in a prediction of about 8 crashes per year, where 3 of these may result in injury. An interesting thing about the safety conditions was for the future roadway was that single vehicle crashes are actually 3 times more likely than multi-vehicle crashes along the future corridor. And then at the intersection of Escalante Road and Houghton Road, an additional 5 crashes per year can be expected at the intersection specifically, where 3 of these have the ability to cause injury. And moving on, I will discuss the intersection performance. So to assess the intersection at Escalante and Houghton Road, the level of service can be used to determine if the roadway is being utilized efficiently for vehicle traffic. This is important in determining the future roadway will be over or under designed. And so the existing roadway was operating at a grade A, as you can see in the top figure, along Houghton Road specifically. Although this seems to be good, it actually means that the roadway is being underutilized. And so when comparing this with the future roadway level of service, it may seem as though the level of service worsened during those specific approaches since they decreased the letter grade, but that actually displays that the future roadway is better utilized than the existing corridor. So moving on, I will discuss Secrist Middle School flow and parking. So the current parking lot available to the public is 44 spaces with an additional side lot of 25 spaces that serve faculty and staff population. Those can both be seen on the upper image on the slide. Based on the City of Tucson ordinance, 46 spaces are required to serve this school for both public and faculty and staff populations. From the current parking, you can see that that meets that more than 46 spaces because you have the sum of the 44 and 25 spaces. So because of this, it is recommended that no additional parking be built because it will just go underutilized. So because of this, the ratio of public parking to faculty and staff parking should just be adjusted to best utilize what's already existing there. And then if you look down at the bottom figure, that will display where the new drop-off and pickup area for parents will be. This will be moved south of campus, and this location will allow the drop-off area to hold many more cars and also remove that congestion that can be seen in the existing parking lot and even the existing surrounding roadway due to the congestion that comes with the pickup and drop-off. And then a Pelican crossing will also be implemented just north of campus. This location was chosen because it will provide pedestrians with a safe crossing option, as well as allow vehicles turning in and from the school to have an opportunity to turn onto Houghton Road without kind of having to deal with the moving traffic that can be seen at these peak times. So moving on, I will discuss the alternative transportation methods that are implemented throughout the roadway as well. So in addition to the recommendations mentioned above, the recommendations are also made in regards to alternative methods of transportation. So the shared use path that is south of the project that's existing will be expanded throughout the entirety of the project bounds. This will provide both pedestrians and bicyclists with a safe option that gives them a sense of safety because they'll be separated from the roadway. The shared use path will also connect with the Pelican and provide safe crossing for the middle school users. In addition to the shared use path, there will also be bike lanes on either side of the roadway that will be painted green. This will allow bicyclists to travel in either direction while enhancing awareness of vehicles to watch out for bicyclists, since the green paint will kind of draw to the bicycle lane more than just an unpainted striped bicycle lane. It is also important to note that with the alternative enhancements that I've already mentioned that pertain to bicyclists and vehicles, this will also improve safety for vehicle users because they'll be more aware and separated from these alternate transportation users. Additionally, bus pullouts will also be implemented within our design. Although there aren't any routes applied right now throughout the corridor, there will be in the future, so that's an option that they have to easily implement those. A bus pullout will be implemented at Secrist Middle School, moving southbound. And the nice thing about this is this bus pullout will also act as additional school bus pickup and drop-off space. And then there will be an additional bus pullout north of Houghton and Escalante. So moving on, I will let Daniel inform you about our drainage plan.
Thank you, Kristen. For the drainage portion of this project, drainage locations, their existing conditions, and proposed changes. On the left side of the screen, you can see the project map that shows the Old Spanish Trail Wash and Pantano Wash crossing. On the right side, the culvert and storm drain locations are shown. There is a total of Drive and Irvington Road. On the next slide, I will go over the HECRAS analysis for the Pantano Bridge. So for the Pantano Bridge, I obtained the results by running the existing model given to me in the HECRAS software. This showed me that the freeboard clearance did not meet ADOT 3-foot requirement. With this information, we decided to raise a new bridge in order to meet ADOT requirements. In this slide, the table shows the existing conditions for each culvert crossing shown in the first slide. On the next one, it shows the proposed changes to these culverts due to not being effective, and getting this analysis by running HY8 to propose the changes for these culverts. So by running it in HY8, I determined that 3 out of 7 culverts and 1 storm drain needed to be changed. This being said, now we have Jason with Geotech.
Thank you, Daniel. So to give you guys a geotechnical summary, soils at the site generally were made up of sand with silts, silty clay, and gravel. Based on geotechnical evaluation, this project is feasible and the soils are good. Given that we are in Arizona, we could ignore the effects, or in Tucson and in the project area, we can ignore the effects of seismic activity. Faults and fissures should not affect the project, and excavation can be accomplished using heavy duty civil equipment in good operating condition. To give you guys some recommendations, the pavement section, we recommend aggregate base of 11 inches and asphaltic concrete of 6 inches. For foundation design, we recommend a drilled shaft that must support 1,100 kips. More detail could be found in the full report. And something to keep in mind for the longevity of the project is the soil types. There are fine grained soils found throughout the corridor, and these may have some shrink and swell properties that may affect the project and the structures over time. So I will now pass it to Tariq, who will talk to you about the structures.
Thank you, Jason. So as you know, the bridge makes up a big part of this project, at least in terms of cost. And as you already know, the existing bridge does not accommodate the expansion of the corridor as it does not have enough capacity for traffic flow. As such, we propose a new bridge configuration that is composed of two new bridges, as shown in the plan view. One new bridge will be immediately to the east of the existing bridge, and another bridge will be on top of the existing one to be built after the existing bridge is demolished. And this design allows for the continuous flow of traffic throughout the period of construction. And the details of how that works will be covered by the construction team. For our bridge selection, we came up with 3 alternatives highlighting different superstructure configurations, varying in number of spanning, in girders, and in deck thickness. The first alternative utilizes ASHTO Type 2 girders spaced at 10 feet to support a 9-inch deck, and that sits on a whopping 7-span structure. The second alternative utilizes ASHTO Bulk T girders spaced at 10 feet to support an 8.5-inch deck, which sits on a 4-span bridge, matching the existing condition bridge in terms of spanning. Alternative 3 utilizes ASHTO Type 5 girders spaced at 8 feet to support an 8-inch deck, sitting at a minimal spanning of 3-span structure. And at ABA, our job is to propose a bridge design that is cost efficient, environmentally sound, and feasible to construct. And using these values, assigning them to these alternatives, we came up with the following analysis. Next page. So alternative 1 is the least costly option in terms of superstructure, sitting at $430,000. However, it is the most difficult to construct bridge as it utilizes a large amount of spanning, and it is the most disruptive option as it introduces much obstructions to Pantano Wash. The second alternative sits on a reasonable superstructure cost of $588,000 and is fair in terms of constructability and environmental impact. Alternative 3 is the most costly option, sitting at $782,000. However, it is the most easy to construct bridge, and by consequence, it is the most easy to construct bridge due to its minimal number of spanning, and by consequence, it is the least disruptive alternative. So weighing in the advantages and disadvantages of these multiple alternatives, we decided that alternative 2 is the best fit option for this project, as it nicely balances cost, constructability, and environmental impact. And next will be Stefan covering retaining walls.
Thank you, Tariq. So to ensure value engineering for this project, we wanted to use retaining walls rather than a sloping system. In the picture, you can see that most of our all of our retaining walls are located between Irvington and Escalante Road. We are utilizing 2 types of retaining systems. We're using a concrete cantilever retaining system, as well as a mechanically stabilized earth structure. For walls up to 15 feet, we're using the concrete cantilever system, and then walls greater than 15 feet, we are using mechanically stable earth structures, or MSE walls. I want to point out 2 walls that we will build. The one at Station 381 is utilizing both. One for the concrete cantilever, it's up to 15 feet, and then we're above that. For the remaining 10 feet, we're using the MSE wall. This is due to provide less foundation structural systems in it. And then for the Station 386, we're just using the MSE wall due to the fact that for constructability, it's much easier just to use one wall in this spot. Now I'd like to turn it over to Corey for the environmental aspects of this project.
Thank you, Stefan. So the environmental group was put in charge of creating the most sustainable road possible, and this was looked at in the areas of environmental consideration, cost, and most importantly, safety. Overall, the Envision software is what lets us quantify these more subjective sustainability goals. So the area of Houghton Road is found to be in a very vibrant neighborhood community. So these categories outlined on this slide give us the direction on which disciplines can work together, and where we can actually create a better project in our design. So after analysis of all these credits, we were awarded with a gold rating on Envision, which ABA takes great pride in. So outlined on the next slide is the areas in which we excelled to match our sustainability goals. Leadership allows us to look at a top-down approach in all disciplines throughout the design and construction process to complete and create new sustainability, and look at how we can create the best value for the city. And this was shown throughout Tariq's slides showing the bridge design process. Additionally, every aspect of the community was utilized through allowing stakeholders and public to come give concerns and be informed throughout this process. This allows us to create a shared use path to enhance these features for the public. And finally, we focused on maintaining the characteristics that make Houghton Road great. And so this includes the ecological sites found, especially around Pantano Wash. This was kept intact with the help of a stormwater pollution prevention plan and working with the construction team to create the safest phasing plan possible. And to outline this phasing plan and a little bit more of what goes in the construction process, I'll hand it over to Ethan and the rest of the construction team. Thank you.
So with the communication and collaboration of our design team, they were able to have minimal effect on the Tucson Electrical Power's utility lines. And we'll be working with the City of Tucson for ample notice of any community impacts. We'll be working with Tucson Unified School District for safety guidelines throughout the construction process and the services Banner Health provides. And then moving into the construction phases, there will be 3 phases a part of this project. Phase 1 and 2 are going to be dealing with the roadway. And we're going to be beginning with phase 1 on the west side heading north of Houghton Road. And we're going to start at Secrist Middle School because this high congested area we think would be most beneficial to get the construction of this area done first. And then we'll be able to work with the bus stop and new turn lane that we're going to be implementing. And then once we finish the construction in front of the Secrist Middle School, we will then be able to move down the west side of Houghton Road. And at the completion of the west side, we can then move into phase 2, which is going to be the east side of Houghton Road, along with the culverts mentioned by Daniel. And then during phase 1 and 2, we will also be constructing phase 3, which is the Pantano Wash Bridge. Since this is a key aspect, we need to be constructing this during phase 1 and 2 to allow the project to finish as early as we can. And we'll be leaving the existing until the completion of the new bridge, and at that time, then we can demo the Pantano Wash Bridge and divert all the traffic to the new Pantano Wash Bridge. And then the last key aspect in the construction phasing will be the Escalante intersection, which will be shown in the next slide. Just like phase 1 and 2, we think it's most beneficial to demo the west side of Houghton Road at this intersection and then move into the east side. And with the expansion of the road, we think it's most beneficial to improve this. And also, we will improve the traffic and lighting signals at this intersection, and we will provide pedestrian barricades represented in the detail in the orange, just so bicyclers, students, or anyone that needs to get through the intersection have safe travel. And we will also have new clear visual travel lanes for drivers to be able to understand which are the correct left, straight, or right turn lanes throughout this construction process to minimize accidents. And we'll also have traffic officers and traffic control throughout this entire process to aid in safety and traffic flow. And now Jesus can go over the preliminary estimate.
Thank you, Ethan. Hello, everyone. My name is Jesus Ruiz, and I'll be talking about cost estimate considerations and also about the cost estimate breakdown. First, we have to acknowledge that we are using a CMAR procurement process, which stands for Construction Manager at Risk. And that allows us to work closely with the design team early to talk about constructability, as well as to address their needs such as environmental work and traffic flow. Our estimate is based on 30% drawings, and we are using a square foot method as we do not yet have the details for the drawings, like the full details. Yet we know that we are not far off from our final value, and we will use this as a base for when we get more complete drawings. We mostly focused on demo, bridge work, and traffic control in this estimate. Here we have our spreadsheet, and I know there's a lot of items, but the important thing to take away from here is that we have been recording our assumptions for future, more detailed estimates. This will ensure that if we do make changes, we can understand the difference in our cost. Our goal is to lower the price for the owner. Next slide, please. Our construction subtotal is $8 million, but our total project cost is $15 million, considering costs outside of just the construction items, such as contingencies, which we have estimated at 40% of the total construction. We will lower this price once we get better detailed drawings, and then we will actually have a better estimate once we're at 60% and then at 90% and then at completion. So I will now return the stage to Travis.
Thank you, Jesus. So where are we going from here? What's our plan moving forward? We believe that from day one, this is a team effort. So we would like the owner to provide feedback on any desired or anticipated changes that may result in cost-saving measures as soon as possible. This will give us ample time for the design team to reevaluate and provide addendum to reflect these changes, as well as update our schedule and our cost estimate. So we just completed our initial design concept report this month, May 2020. So we are on track to start tightening up our detailed design activities for the next year and a half. And if all goes well in between then, we hope to start our year and a half construction duration in the spring of 2022. And before we conclude, I just wanted to emphasize a few characteristics of our design that I feel are worth noting. We're confident that this design checks all the boxes and needs for what you, the owner, are looking out of this project. This next line on it is a typo. It's supposed to say value engineering, but we're committed to implementing value engineering wherever possible and do welcome your feedback in that as well. Safety has and always will be at the forefront of the design process, and we feel that our design and our capabilities are adaptable to changes and unforeseen circumstances. With that being said, we'd like to open the floor for open questions.
This is Doug. I'll start if that's all right. You identified you were talking about the project as a CMAR. How did you settle on CMAR over the other alternative delivery methods?
Hi. So CMAR offers more time at the beginning for us to talk with the design team. So that we think it's a better choice for this project, since we can start telling them if their ideas are going to actually work outside in the field, instead of just getting drawings as a typical design build project where you just get the complete sheets and then you have to go from there. Does that make sense to you, Bill?
I'll also add that we felt that it was most appropriate, given that we are a all-in-house engineering and construction firm. We do house all of our engineering disciplines in-house under one roof, as well as a construction management committee on top of that. So the CMAR contract structure felt most suiting for those reasons.
Okay, yeah, thank you. And was it, I think you had that in your cost estimate. You had some slide of your overall estimate there. So yeah, it looks like you've got that factored in. Thank you.
Thank you.
Hi, this is Anna. I also had a question on the estimate. So I noticed that the total cost is almost double of the construction cost. Is that because of the high contingency or right-of-way cost, or what is?
Yeah, so our total project cost is almost double, as you can see, because in our estimate, we put contingencies that we might need to account for in the future as 40% of the construction subtotal. Okay. So once we get more complete drawings and more details on how we're going to approach construction, that price will lower down, because right now there's too many unknowns that we're just factoring that in just a what if case, you know?
Yes, thank you.
Can you tell me about the demolition of the existing bridge? You're going to put the foundations in the same locations as the existing foundations, or are you shifting them off with the spans to a different spot? How is that working with the foundation of the existing bridge and your new foundations?
We will be putting the new bridge to the east side of the existing bridge, and this will just allow for the traffic flow throughout the whole process to be able to be used by the existing bridge. And then at the appropriate time, the demo will not affect the substructure of the new bridge, but this will just allow for steady traffic flow throughout the whole project and no congestion due to not having a bridge.
So the bridge is going to get completely shifted to one side, or I guess, or I missed that completely then. So
yeah, it will be diverted.
Okay, all right. So it's a realignment of the roadway then as well to account for that?
Yes.
Okay.
Sergio, can you confirm?
Yeah, we will adjust the alignment once the final design of the second bridge would be finalized or further along in development.
Good, thanks.
So Kevin, let me just clarify. When you look at the thing right now and the right-of-way that's there, everything's off on the east side of the right-of-way except for the bridge, which is on the west side of the right-of-way. So right now, when you approach the bridge from either direction, you have to veer to the west and then veer back. So, but now when they widen, everything's going to widen to the west, except the bridge has to widen east. So, odd situation unless you really look at the plans. Maybe clarify it a little bit.
Okay. Thanks. Yep.
Hey, Frank, anything?
No, Doug beat me to the Seymour question. I was curious to see why they went that route. So
okay.
I think I'm good. Good job, guys.
All right. There's nothing for anybody else. Thank you all. You did a great job and moved it along well, and good slides and everything. Nicely done. You guys can go ahead and leave. If the judges want to hang out, we can talk for a couple minutes before we switch to the next one.
Thank you, guys.
Thank you.
Thank you, judges.
Thanks, guys.
Okay, well, it looks like Doug left. But all right. Was there any questions anybody wanted to ask before? I should have hung out in the last meeting afterwards, and I forgot. I went away too quickly. So
No, this team did great.
yeah, they did a nice job.
Yep.
Okay, any questions? Don't forget, please, you're going to score each discipline, and then there's a subtotal there, and then there's an overall team effective score, which just kind of how did the team merge together and, you know, transition and whatnot. So that's a score that after the basic scores add up to 90%, and then there's a 10% as to how well, you know, what was the overall team effectiveness to give a total of 100 points. So that's the only reminder. I'll throw it out there. You guys can leave or stay in there and do your scoring, and we start the next one in about 11 minutes.
Okay. I'm not getting 100 points. I have to look.
Well, you should get 9. All the discussion part adds up to 90, and then there's a. So, are you looking at the form I gave you, or are you looking at?
Yep, I just filled it in as I went along here. Yeah.
Okay, so as you go along, then there's a line that says raw subtotals is equal to 90. And then,
Yep, right below that, yep.
and then there's the overall effectiveness of 10 points, which makes it 100.
Okay, yep, I must have got, I thought I had a higher number in there than I thought then, okay, yep. Yep.
Okay.
Thanks.
Oh, no problem.
That's why that's lower, okay.
Anything else for me before I leave, Kevin?
Oh, no, it's just me, yeah, no, I'm good, thanks. No, I was wondering why I was,
Yeah, if you
10
have
points
any,
lower on one, I didn't catch why,
Yeah.
so, okay.
yeah,
That's the reason.
I was trying to make it as simple as possible because it's with so many people talking and whatnot and a little bit of time and whatnot, so. All right.
No, I'm just filling it as I go and it's fine. Yeah, it works out okay.
Yeah.
Yep.
See you at the next one.
Yep. And that's at
6:30.
6:30. Okay. Yep. All right.
10 minutes.
I'm going to grab a quick bite here. Thanks.
All right.